Non-calculator circuits, number 7 through, I don't know yet. Number 7, ooh, I love this problem. What is all this nonsense? What the hey? Exactly. Can't divide by 0, kids. All this question is doing is having you get comfortable with this notation, which we'll be using a ton, by the way. It'll be known soon as the old f of x plus h, which is really, really cool, but here we go. You know, if f of x is x squared plus 5, that f of whatever else is just that thing squared plus 5. So if I put in f of 3 plus h, it's actually going to be 3 plus h squared plus 5 minus f of 3. Now f of 3 is 3 squared plus 5 all over h. You're like, what the heck am I supposed to do with that? Some of you, okay. Method 1. Some of you notice that these 5s can go away. If the 5s go away, then you're left with red flag. 3 plus h squared is not 9 plus h squared. You have to multiply. It's a binomial times a binomial. It's a FOIL. It's a whatever you want to call it, but it is 9 plus 6 h's, because you got the 3h and the 3h, plus h squared minus 9, because I canceled out the 5s, and then cancel out the 9s. What do you know? Look at that. And we've got this, and you might look at this and say, ooh, I'm going to cancel out some h's. Careful. Don't go all mad slashy on me, okay? So if you look at this right here, yes, it is true that you can cancel out all the h's because every one of them has one, but it's because you can factor out an h. And now these h's divide, because h divided by h, as long as h isn't 0, is 1, and you're left with L answer 6 plus h. Hey, that's that. But if you liked it here, you can go, I want to call this 9 plus 6h plus h squared plus 5 minus 9 minus, careful, that's a big problem. People forget to subtract because it's a distributive negative, minus 5. And you're like, oh, 9 minus 9 is 0. Whoops. Oh, I lost something here. The 5s go, the 9s go, but also 14 minus 14 goes. All the constants are gone. So I've got 6h plus h squared, which takes me to here. And this, if I factor out the h again, 6 plus h. Next problem, if the perimeter of the rectangle is 68. Oh, I love this problem. If the perimeter of the rectangle is 68 and the width is 10, this reminds me of good old Pythagoras. Let me try to draw a rectangle with one hand. Yeah. Okay. The perimeter of the rectangle is 68. The width is 10. The width is 10, which leaves me with 48 to be both of these. Well, 48 is both of them. We have to do this magical thing called division, and this is 24, and this is 24, and how long is the diagonal? How long is the diagonal? This says no calculator. You Pythagorean theorem with 10 squared plus 24 squared. Oh, don't worry, mon frere. All you gotta do is remember your Pythagorean triples. If you have a right triangle with sides 10 and 24, you can reduce it by 2 and see your good old buddy, 5, 12. That's right, kids. 5, 12, 13. You remember those. If you don't remember those, then just go square root of 5 squared plus 12 squared. And maybe you remember that 25 plus 144 is 169, and then there's your 13. But the answer is not 13, of course, because you halved it. Is that a verb? Halved it. So now you got to double it. And that's why it's 26. Hey, that's that answer. Exactement. Try to think if there's another way to do that. I guess you could have Pythagorean theorem this here. But 10 squared plus 24 squared is a little bit trickier to do by hand. Some of you were really trying to do that earlier. So you might want to half it, but this is certainly okay. And you could do the whole like da-da-da-da-da-da-da-da-da. And if you don't know what 24 squared is, that's fine. Now, this problem is so cool. I saw so many people doing it different ways today. I saw all these different ways to do it. I think a really, really nice way to do this problem, where is it? Okay, I'm gonna give you the shortcut first because it's kind of cool. The shortcut goes like this. If x squared minus y squared, why would I give you those? Why would they give us those? Wait a minute, I remember this. X squared minus y squared is a difference of squares. So x squared minus y squared is x plus y, x minus y. It's factoring. Factoring to the rescue. But wait, Mr. Mac, x plus y is 7. Uh-huh. X minus y is 3. Uh-huh. Hey, it's 21. You bet your bottom dollar it's 21. 21. 21. What a great answer. But that's not what I did, Mr. Mac. I did a lot more complicated, like, I know. So check this out. You're done. We can keep going. That's cool. But watch this. Somebody was doing this earlier and I loved it. Let me see if I can do this. If x plus y is 7, doesn't that mean that x is 7 minus y? And if x minus y is 3, doesn't that mean, maybe I should go the other way, that y is 7 minus x, and then x is 3 plus y? Oh, this is going to get me anywhere. Anyway, some of you were trying this a little bit earlier. So x squared then is this squared. Foiling, 49 minus 14y plus y squared minus, oh, actually, you know what I'm going to do? I'm not going to substitute that because this is x squared, and I'm going to subtract y squared, which means my y squareds cancel out. But what's y? This isn't getting me anywhere. Y is x plus 3. Ooh! If y is x plus 3, no, that's not getting me anywhere. Ooh, ooh. X plus y is 7x squared minus, well, I think I'm going in I'm a little bit not sure. So maybe I won't do that way. Maybe I'll see this. But if somebody found a nice algebraic way to do, I just don't want to make the video too long. But if somebody did a nice algebraic way of doing this and it worked, and you'd like to share it with me, I'd love to hear it because I'm a huge fan of doing problems 4, 5, 6, 10 different ways, but there should be a nice cleanish way. Maybe a little bit of a letdown with how nice this was, but how great is that? It's 21. Let's go to this problem. It has a solution of 21. Now this one is we need to talk about this one. If you read this as g to the negative 1 as 1 over g, which is the correct notation, this was a problem that was meant to be an inverse. Okay, so this is bad notation talk, and we'll do this. We'll talk about this a lot. But bad notation talk means we should have never, math people should have never used this notation as an inverse. But whenever you see this, it does mean that g is an inverse of f. F is the inverse of g. And inverses, inverses are things where you flip the x and the y, or you flip the x and y and solve for y, or whatever you want to do. I want to find the inverse. Now, you're not gonna graph this and remember, like, inverses are like, oh, look at that graph. Let's find the inverse. Oh yeah, and it's a reflection of line y equals x, and everything flipped, like the point 1, 3 becomes a point 3, 1, and stuff like that, which is super cool. But let's just do this instead. If g is that means y equals 2x over x minus 1. But I got to find the inverse, which means I have to switch the x and the y, you know it, dun dun dun, the great swap, and solve for y. How the heck do I solve this for y, Mr. Mac? Exactly. Watch this magic. I got to get a y all by itself. Seemingly impossible because they're all embedded over here in the right rational expression. But watch this. If you multiply both sides by y minus 1, right? Multiply both sides by y minus 1, it cancels out here and it's over there. And then if you distribute xy minus x, and you're like, well, that didn't get me any closer to solving for y. Oh, sure it did, because now, you got two options here. I'm going to subtract 2y off both sides at the same time as I add x to both sides. Why in the world would I do that? Because watch. Even though it seems like y can't be found by itself, it can very simply, because if you factor out the y, then you're left with this y times something equals x, and you can just divide both sides by x minus 2, and y is equal to x over x minus 2, and now you just plug in 5. That is the inverse, my friends. That's the inverse, which is kind of cool. This is the inverse to g. Stick in a 5, you get 5, y of 5, g of 5, whatever it is 5 over 5 minus 2, which is 3 5/3. Mr. Mac, that's not what I did. I brought it to the brought it to the left side. I went xy minus 2y equals x. I added x to both. That's what I already did. I went, which was the other way? I brought the digga. So negative x equals 2y minus xy. This is what I did. Negative x equals, factor out the y, 2 minus x. This is interesting because now y is equal to negative x over 2 minus 6. You're like, that's not what we had before. But actually, it is. That's why there was the rule on your sheet that said a minus b over c minus d is the same as b minus a over d minus c. What? I've never seen this before. This is ridiculous. Well, it's kind of like a made-up identity because if you just multiply the top and the bottom by -1 distributively, negative a plus b, it's the same thing. And who's to tell you which way to do your algebra? Besides, it doesn't matter. Just stick in your 5 because -5 over 2 minus -5 over 2 minus 5, -3. Hey, look, that's 5/3 again. Bingo. 5/3. If you need a retalk on that one, rewatch that or talk to me. 5/3. Solve for, oh, you remember that good old log rule, log A. Sorry, log base B of A minus log base B of B is log base B of A divided by B. Subtraction is division. Addition is multiplication, blah, blah, blah. So if that's true, that means that if you have the same base, which these do because they're both natural log base E, that ln of x minus ln of quantity x plus 2 is really ln of, referencing what rule? I use this rule. Equals 1. You're like, how am I supposed to get x by itself? Do I have to do that weird stuff I did up here? No. If ln of something equals 1, you've got an e hiding here. E to the 1 is x over x plus 2. How do I get x by itself now? Do I have to? Am I supposed to? I am. How do I get x by itself now? Well, let's do that trick we did in the last one. It's almost like these are building, right? It's cool. So let's multiply both sides by x plus 2. Let's distribute in the x. Ex plus 2e equals x. Let's get all the x guys to the same side. Let's subtract that over on that side. And now if you factor out the x, you're left with e minus 1. So x is negative 2e over e minus 1. But oh no, that's not the right answer. Oh, there's that rule that we had up there. So all I'm going to do is multiply this by -1 over -1 because I'm allowed to, because that's just 1. Anything over itself is equal to 1 as long as it's not 0 or infinity. We'll talk more about that. And this becomes positive 2e over negative e plus 1, which I will commutatively call 1 minus e. Bingo bongo. Last one. Maybe 7, 8, 9, 10, 11, 12. We'll call this number 12. Number 12. As x grows infinitely large, what is the value of that as approaches what number? Now, if x grows infinitely large, some of you might say, isn't this thing called a limit? Now, we'll talk about this next week. A limit as x approaches infinity of 2x over 5x plus. Can I just do that? Slow down, slow down. Yes. But let's go here. As x grows infinitely large, really, really, really big. This is 2 times huge. This is 5 times same huge. Plus 8. Plus 8. If x was like 2, this 8 makes a big difference. But if x is like a bajillion, 2 huge, 5 huge, plus 8, how much does this 8 really affect anything? So I'm going to use very loose notation right here. 2x over 5x plus 8 at infinity is really just 2x over 5x, isn't it? Like the 8 is really, we say insignificant. The 8 really doesn't affect that much. And because I'm going to infinity, these x's will be the same. I'm not dividing by 0, which is fine, and I get my 2/5. You might recognize this as, how do I find a horizontal asymptote, which is exactly what we just did, and that's 2/5. And that, my friends, is problem 7 through 8, 9, 10, 11, 12. Second half coming soon. Thank you for watching video number 2. Oh, I said I was going to say something interesting about myself. I grew up in Canada, but I was not born in Canada. You'll have to watch the next video to find out where I was born, if I remember to say. See you next time.